The MathAcademy.net channel welcomes you to see how mathematics anxiety can be cured with 1 cup and 7 sticks, through recounting and cup writing. And welcomes you to Mathematics as Many-matics, a natural science about many. Sticks are counted in 2 ways, as ones, or as bundles. 4 sticks are counted as 4 ones, or as a bundle of 1 fours, that can be rearranged into a 4 icon, with 4 strokes. 3 sticks can be rearranged into a 3 icon, with 3 strokes, if written in a less sloppy way. Likewise with 2 sticks. And a bundle of 5 sticks can be rearranged into a 5 icon, with 5 strokes. In this way we create icons until the number 10, that has no icon. Counting in 5s, we count 1, 2, 3, 4, bundle. 1 bundle 1, 1 bundle 2, etc. Here we use no 5 icon. Counting in 7s, we count 5, 6, bundle. 1 bundle 1, 1 bundle 2, using no 7 icon. Counting in 10s, we count 8, 9, bundle. 1 bundle 1, 1 bundle 2. So when counting in 10s, we need no 10 icon. To master many, we ask how many. To answer, we count by bundling. Counting a total T of 7, we say 1, 2, 3, 4, 5, 6, 7. Counting a total T of 7 in 3s, we say 1, 2, bundle. 1 bundle 1, 1 bundle 2, 2 bundles. 2 bundle 1. We use a cup to separate the inside bundles from the outside unbundled singles. The cup becomes a bracket when using cup writing to report that a total of 7 ones can be counted as 2 3s and 1, or as 2 bracket 1, 3s. Once counted, a total can be recounted. Moving a stick from the inside to the outside creates an overload. Thus a total of 2 bracket 1, 3s, can be recounted as 1 bracket 4, 3s. To create an underload or deficit, we borrow foreign sticks, in order to move a bundle of 3 ones, from the outside, to 1 extra bundle, in the inside. Thus a total of 2 bracket 1, 3s, can be recounted as 3 bracket -2, 3s, or 3 less 2, 3s. In this way a total can be recounted in 4 different ways. A total of 7 can be recounted as 2 bracket 1 3s, or as 1 bracket 4 3s, or as 3 bracket -2 3s. A total of 7 can be recounted as 1 bracket 2 5s, or as 0 bracket 7 5s, or as 2 bracket -3 5s. A total of 9 can be recounted as 3 bracket 0 3s, or as 2 bracket 3 threes, or as 4 bracket negative 3 threes. A total of 6 8 can be recounted as 6 bracket 8 tens, or as 5 bracket 18 tens, or as 7 bracket negative 2 tens. A total of 3 6 8 can be recounted as 3 6 bracket 8 tens, or as 3 5 bracket 18 tens, or as 3 7 bracket negative 2 tens. To add, we use recounting and cup writing. Using cup writing to add 27 to 65, we get 8 inside and 12 outside the bundle cup. To remove the outside overload, we move 10 ones from the outside to the inside as one bundle. So the result is 9 inside, and 2 outside, or 92. Alternatively, before adding 27 to 65, we create an underload outside, by borrowing 3, to move 10 ones from the outside, to the inside, as one bundle, thus recounting 27, as 3 bracket negative 3. That added to 65 gives 9 bracket 2, or 92. To subtract, we also use recounting and cup writing. Using cup writing to subtract 27 from 65, we get 4 inside, and negative 2 outside. To remove the outside underload, we move one bundle from the inside, to the outside as 10 ones. So the result is 3 inside, and 8 outside, or 38. Alternatively, before subtracting from 65, we create an overload outside, by moving one bundle from the inside, to the outside, thus recounting 65, as 5 bracket 15. If we subtract 2 bracket 7, we get 3 bracket 8, or 38. To multiply, we also use recounting and cup writing. Using cup writing to multiply 48 by 7, we get 28 inside, and 56 outside. To remove the outside overload, we move 50 ones from the outside to the inside as 5 bundles. So the result is 3 inside, and 6 outside, or 336. Alternatively, before multiplying, we create an underload outside, by moving 10 ones from the outside to the inside as one bundle, thus recounting 8, to 5 less 2, tens. Multiplying by 7, we get 35 inside, and negative 14 outside. To remove the outside underload, we move 2 bundles from the inside to the outside, as 21s. So the result is 3 inside, and 6 outside, or 336. To divide, we also use recounting and cup writing. Using cup writing to divide 336 by 7, we prefer to have 28 instead of 33 inside the bundle cup, so we create an overload outside by moving 5 bundles outside as 51s. Now we have recounted 336 as 28 bracket 56, which divided by 7 gives 4 bracket 8, or 48. Alternatively, before dividing, we create an underload outside, by moving 21s from the outside to the inside as 2 bundles. Now we have recounted 336 as 35 bracket negative 14, which divided by 7 gives 5 bracket negative 2. Taking one bundle outside as 10 ones, this can be recounted as 4 bracket 8, or 48. To divide 338 by 7, we recount 338 to 336, plus 2 leftovers that counted in sevens becomes a fraction 2/7. So 338 divided by 7 gives 48 and 2/7. When counting by bundling and stacking, the unbundled singles can be placed in 2 different places. Placed on top of the stack, counted as a bundle, the 3 singles become a fraction, 3/5. Placed next to the stack, counted as a separate stack of ones, the 3 singles become a decimal fraction, 3/5. To recount 9 in 4s, we bundle and use a bundle cup with 1 stick per bundle. We report with cup writing or decimal writing, where the cup or the decimal point separates the bundles from the singles. The result can be shown on a Western abacus in geometry space mode, or in algebra time mode. In geometry mode, we place the singles on the bottom line, and on the lines above, we place the stack of bundles. In algebra mode, we place the singles on the bottom line, and on the line above, we place the number of bundles. In algebra mode, we reserve the next line for the number of bundles, etc. Counting creates division and multiplication and subtraction, also as icons. From 7 take away 3s, we write 7 uphill stroke 3, iconizing the sweeping away by a broom, called division. 2 times stacked 3s, we write 2 cross 3, iconizing the lifting up by a jack, called multiplication. From 7 take away 2 3s to look for unbundled, we write 7 stroke 2 cross 3, iconizing the dragging away by a trace, called subtraction. The counting process includes division, multiplication, and subtraction. To find the bundles, we divide. And to find the unbundled, we subtract. A calculator can predict the recounting result by using 2 formulas. The first formula says that from a total t, t divided by b, is the number of times b's can be taken away. The second formula says that from a total t, t minus b, is left, when b is taken away and placed next to. So, to ask the calculator predict the result of recounting 9 in 4s, we enter 9 divided by 4. The result, 2. Sum, tells that a 4 bundle can be taken away 2 times. To find the unbundled, we enter 9 minus 2 times 4, leaving 1. The calculator thus predicts that 9 can be recounted as 2.14s. To change a unit means recounting in a different unit. Asking 3 fours is how many 5s. We can find the answer in 3 different ways. Using sticks, we can debundle and rebundle the 3 fours to get 2.25s. A calculator prediction gives the same result, as does an abacus in geometry mode, where the top 4 bundle is transformed into 2 ones, changing the 4s to 5s, and 2 unbundled for the bottom line. To change a unit is also called proportionality. Asking 3 sevens is how many 10s means recounting in 10s, which can be done in 3 different ways. Using sticks, we can debundle and rebundle the 3 sevens to get 2.110s. An abacus in geometry mode gives the same result. A calculator has no 10 icon. Instead, the calculator gives the answer directly, but without a unit and with misplaced decimal point, by writing 2.1 instead of 2.110s. Recounting to tens is called multiplication tables. Asking 29 is how many 6s, means recounting from tens, which can be done in 4 different ways. Using sticks, we can debundle and rebundle the 2.910s to get 4.56s. A calculator prediction gives the same result, as does an abacus in geometry mode. Being the reverse of counting to tens, counting from tens can also be called solving an equation asking what to multiply by 6 to give 29. Now, 29 can be recounted in 6s as 29 divided by 6, times 6. So the solution is 29 divided by 6. This gives us a method to solve equations. Move to the opposite side, with the opposite sign. Double counting means recounting in another physical unit, which creates per numbers. Double counted a quantity as 4 kilograms and as $5 creates the per number 4 kilograms per $5, or 4 per 5 kilogram per dollar. Asking 7 kilograms gives how many dollars. We get the answer by recounting the 7 in 4s, so many times we have $5. Likewise, when asking $8 gives how many kilograms, we recount 8 in 5s. So in both cases we just recount in the per number. Double counting is also called proportionality. Once counted, totals can be added. But how? On top or next to? Apparently, division, multiplication and subtraction are well defined, but with 2 options, addition is not well defined. To add on top, the units must be the same, so here we need to recount one of the units. To add next to, the stacks and their areas are integrated, which is called integration. Counting in tens only, you don't need to change the unit. And you cannot add next to. So you will not meet proportionality or integration or its reverse, differentiation, at an early age. To try out recounting and cup writing yourself, you can download the short version of the booklet called Math Anxiety Cured with 1 Cup and 7 Sticks. Teachers or parents wanting to learn more about recounting and cup writing can arrange a one-day Skype seminar designed to investigate the child's own two-dimensional numbers as observed when showing 4 fingers together 2 by 2, makes a 3-year-old child say, "No, that is not 4, that is 2 twos." At the seminar, in the morning you listen and discuss the difference between good and bad and evil mathematics. In the afternoon you try out the full version of the booklet called Math Anxiety Cured with 1 Cup and 7 Sticks. The seminar includes 2 Skype conferences, one at noon and one in the afternoon. The mathacademy.net is designed to teach teachers to teach mathematics as many-matics, that is, as a natural science about many. At the mathacademy.net, teachers learn about many-matics through the CATS method, count, and add in time and space. The material has a question and answer format, allowing concrete activity learning at the primary level, and gossip learning at the secondary level. In pyramid education, a group of 8 learners are organized in 2 teams of 4, choosing 2 instructors, and 3 pairs, by turn. Each pair works together to solve count and add problems. The coach assists the instructors, when instructing their team, and when correcting the count and add assignments. Each learner pays, by coaching a new group, of 8 learners. Alternatively, teachers can try out 8 micro-curricula designed for carrying out action learning or action research in recounting and on top and next to addition. Action learning and action research can be inspired by skeptical thinking, wanting to unmask choices that are masked as nature. In action learning, you uncover alternatives that allows you to redesign and to teach your lesson plan. You learn from your observations, and from sharing these with your colleagues. This allows you to again redesign and teach your lesson plan. After several cycles, you might try to publish your work to unmask false nature. The mathacademy.net channel hopes that you have enjoyed this video, and welcomes you to other videos and material, presenting mathematics as many-matics, a natural science about the physical fact many.